Hi, everyone. I guess we can begin. It's 3 p.m. sharp, and I think if I'm too late, they will not let me back into Switzerland. I have to be on time. So let's go ahead. My name is Alina, and today in this session, we will talk about GraalVM, and namely native image and all the things that you need to know to safely and confidently use it in production, or rather, all the things that I can fit into 50 minutes, because if I'm being honest, that's not too much time. And if that's OK with you, because we don't have that much time, we will not do any slides, because there are many demos that I want to show you, and there are many practical kind of tips that I want to share with you. But if you are more of a visual learner, I will share a link to the slides, so you can have also an equivalent of this talk as slides. I was thinking to also skip the intro to GraalVM, because I was hoping that by now I don't have to do it. But I was at the Oracle booth those past few days, and some people asked me, what is GraalVM? So let me maybe give you a very brief overview of it so we can all be on the same page. Before I do, though, how many of you have heard about GraalVM? Okay, give or take 80%, if not all the room. And how many of you have tried building something with GraalVM, but namely native image? OK, 1/3, 1/4, still quite good. If I convince a couple more people by the end of the session, I will consider my mission accomplished. OK, so this 1-minute overview of GraalVM. So GraalVM is a JDK, just like any other JDK of your choice. So it includes a complete JDK underneath. But also, we have added a few additional features and components on top of your normal JDK. So one thing we have added our own JIT compiler. As you know, in your, let's say, OpenJDK or whatever is the JDK that you use, the top-tier, highly optimizing JIT compiler will be C2. So what we are doing in GraalVM, we are replacing it with our own, and might I say, better, more modern, more highly optimizing compiler. So you can use GraalVM just as a JDK to run your programs with Java, jar, and give it your jar. And this way, you can win maybe 5, 10, if you're lucky, 15% performance improvement just from this easy switch as your JDK. Now, another big part of GraalVM is that we love Java and we run Java. But in addition to Java, we implemented many other languages on top of GraalVM. This is actually something that also many people find interesting. If you want to use, let's say, some cool Python, ML, data science library from your Java, it's very easy to do so with GraalVM. You can pull those languages in as Maven dependencies, and then you can use that Python or JavaScript or whatever library as it would exist in your Java project. So those are two big things, but that is not the topic for today. Today, I will focus on this native image ahead of time capability of GraalVM. And it's a bit hard to explain. That's why I brought this one chart, if the conference Wi-Fi will work with me. OK, so another 1-minute intro to native image. So what native image does is ahead-of-time compilation of your Java program to a native executable. So think of it in a way as you can still write your program in Java as you would normally, but then in the end, you have a fully native executable that doesn't need a JVM to run. So in a way, you have a program as you would have written it in C or C++ or Rust, so it's completely native, but you still write it in Java. And what we do with GraalVM, when you invoke our native image command, we will look at your application starting from its main entry point. So your project needs to specify what is the main entry point to your program. And then from there, we will try to find all the reachable code, so all the code that is actually needed to do what your application is supposed to be doing, so that then we can include only that code into that native executable. And this applies to the code that you wrote, which we call user code, so the things that you actually wrote, but also it applies to the JDK and even the dependencies that you are using. So we will analyze your project as a whole, and then only include the things that you actually proactively need and use in that native executable. Along with it, we will also take a look at your heap and see if there are some things that we can include in your heap, kind of pre-bake at the build time, so you don't need to spend time and resources allocating your complete heap at runtime. So in the end, you have a native executable that is platform-specific. So two important points here, it is platform-specific. So let's say I cannot build, unfortunately, on my MacBook for Windows or for Linux, at least not out of the box. And second thing, this whole process, as you might have guessed, needs to happen under closed world assumption. Because to include everything that needs to be in your native executable, we need to limit at the build time what is known about your project. So everything that needs to happen, you need to tell us in a form of configuration when we are building your application, and then nothing unknown can happen at runtime, because otherwise we cannot build this project ahead of time. So this is our quick intro to GraalVM and native image, and now let's take it for a spin. The first thing I want to show you here is, as you can guess, here is a dictionary application. Let's quickly check our Java version, and here I'm running on GraalVM for JDK 24. So it's very easy to remember when you get a new GraalVM version, because every time there is a new Java release, there is GraalVM release on the same day. So if I can suggest, if you want to have the latest Java distro, you can just download GraalVM, and you will have the latest of Java features and GraalVM features all in one release. And here's actually, I also want to make a point. Sometimes when I'm at conferences, people ask me, they want to ask you this kind of tricky question as a speaker, when is not a good time to use GraalVM? So what are the downsides, bad use cases? And my answer to that is always use GraalVM. Yes, I work with the GraalVM team. But also, there are many things you can choose from. So if you want a fast JDK runtime, use GraalVM as JIT. If you want fast startup, low memory usage, use native image. If you want polyglot capabilities, bring other languages. So there is no reason for you not to use it. You can always find a part that works for you and your specific use case. With all that being said and done, let's run our project. And it's a Spring app. So let's run it with Maven Spring Boot run. And this all runs on a dedicated cloud instance, so hopefully it should be a nice and clean environment to make demos, not interfering with my local machine. So our application has started, and it started in 2.5 seconds. Let's go ahead. Very good time to update my plugins, I think. Let's go ahead and check our endpoint, and the endpoint is translations. So here we have our dictionary app returning for us a list of translations. One of them is obviously in English. Can anyone guess what is the other mysterious language here? A lot of people here familiar with Swiss German. Very nice. It's a very fun language. If you happen to speak High German, I encourage you to look into Swiss German. It's very nice and cute. I'm not very good with umlauts, but my favorite here might be Büsi, which is a cat. And by where I live, there is a lake called Büsisee, so a cat lake. It's a very fun language. I really like it. But long story short, without derailing, this is our app that returns these translations on the endpoint. But it started, as we have seen, in 2.5 seconds, and I think we can do better than that. So let's move this application to GraalVM, and let's see if we can compile it to native. So if you want to migrate your existing project, maybe after this session, I convince you to try GraalVM. If you want to move any project to GraalVM, one thing that I would encourage you to do is to go to Native Build Tools. The website looks like this. And this is our project where we develop Maven and Gradle plugins that will help you build applications with GraalVM. Doesn't matter if you prefer Maven or Gradle, you can just choose whatever. Let's say we want to go with Maven. And long story short, what you need to do is to grab this plugin and add it to your project. And this will help you build your project, but also will help you making your libraries work with native image. So as a first step, I highly encourage you to go with one of our plugins. But since my project, this dictionary, is a Spring app, I can maybe also go with the more native solution for Spring. And for that, I would go to start with spring.io. And here, I really appreciate that this page now remembers my default. So it's always latest Java for me, and it's always Maven. That's very nice. And let's say I want to add native image. So if I go to my dependencies, and I click on native image, and then I go back here, I see that this added to my project structure this native Maven plugin. And the page is from the Spring team, but the plugin itself, as you can see, is being developed by our team. So if you happen to be a library or framework author, or like being in touch with one, if you want to make sure your project works with GraalVM, this would be the best way to make it native to GraalVM. I would suggest that you add this plugin. So let's go ahead and grab the plugin. And let's go back to our project. OK, dictionary, and this is my POM XML. So let's add our plugin. Now, I can compile it as is, but I want to make this session a bit more practical and share with you how I would do things if I was working with this kind of application. So one thing that I would do here is I would add a configuration block. And within that, I want to add additional arguments to my build. So this will be build args, and the actual syntax for a particular argument will be build arg. So let me just add this one and click the compilation process, and then we'll talk about what this just did for us. Okay, this is on, so let's do maven p. Okay, let's maybe move this higher up. Typo, yeah. Okay, this started, so now this whole thing that I explained in the beginning will go on, where native image and GraalVM look at our project, and they'll try to find everything that is reachable within my project to put it into that native executable. And as it compiles, we can talk about the project some more. So for example, here, my project, it's not even that big. It's a pretty standard Spring app, where we have our main class, we have our controller for interaction with the user, we have our repository, and we are getting data from H2, and also we have service. So overall, it's not that big. So the classes that I wrote myself, it's maybe 5 classes here. But let's look at the analysis that native image is doing in the meantime. So for my project, which is a demo consisting of 5 classes, native image has discovered that as it looks at our project, it sees 33K reachable types, 51K reachable fields, and almost 187, even a bit more, 1,000 reachable methods. So the reason I'm showing you those stats is because whenever I build this at a conference, people come to me and they say something like, Alina, oh my God, those native image build times, I have tried this at home, this is so long, why does it have to be so long? I don't have the attention span. I understand you, I also don't have the attention span. But check this out. So for my fairly trivial project, this is the complexity that is hiding underneath, right? I'm using the JDK, I'm using Spring, I'm pulling in my dependencies. And this is a nice developer experience. It makes me productive, and the whole platforms make my program fast as a Java application. But this also means that there is a lot of complexity under the hood in our Java projects that bring us this developer productivity and performance. So for native image, to understand your complete project and wrap it up into a native executable, I would say this is decent time. But that configuration block that I have added, if we go back here, what this does, this is kind of a development mode. So this is saying, please skip some of the compilation phases because I'm not ready to deploy to production yet. I still want to get my build fast back to me so I can verify that it still works. So this is saying, don't optimize for speed. I don't care about speed yet. I'm still developing the app. When I'm ready to deploy this application to production, what I would do, I would either remove this flag, and then you are relying on native image and the default behavior to optimize for peak throughput, or you can manually specify that I want, let's say, the best possible peak throughput by saying -03, and that will apply all the possible compile optimizations. So with the quick build mode, our application compiled in 1 minute. I would say this is not too bad for a fully blown Spring app. And then if I wasn't using this quick build mode, it maybe would have been 1 minute and 30 seconds. So this is still realistic. And as an output, we get a bunch of files courtesy of AWT. But what we actually need is this dictionary where it says executable. So let's go ahead and run this target dictionary. And it started now in 151 milliseconds as opposed to 2.5 seconds. And if we go back just to verify that it's still working and functional, we can see that it does return the same output. So it still is the same application, but now it's much smaller and it also starts much faster. But this is not the only benefit of native image. If you have heard anything about native image at all, you might have heard that applications built with GraalVM and native image start fast, but that is not all that native image does for you. Let's do something else here. So let's again run our application and do quick, not even performance benchmarking, but let's say resources usage measurement. For that, we will just use the time command, and we will run the same application. So here it starts again, and I will go back and quickly emulate some kind of load, not high load, but it's not idle. It works, it does something, it's just not under a very high load, but it is still functional. So as I stop this, let's say we have sent 15-ish requests in the span of 3-5 seconds. What we see here is how many resources our project has occupied. And there are many things that we can drill down into here, but I would like to focus on two things. One is that the amount of CPU that this job got is 1%. So out of all the CPU that I have on this machine, tell the application use whatever you need, it only is used 1% of the CPU. Granted, it is a trivial application, but it gets a job done. So you probably can have something like that deployed in production, returning some data on the endpoint, and you can have it running at 1% CPU. Even a bit more interesting, I would say, it also consumes at about 140-ish megs of RAM, and I was not even limiting the application's memory usage in any way. I just ran it as is, and I said, use whatever you want from this machine. The whole machine is yours. And even with that permissions, it still used, I would say, 140-ish megs of RAM. So I would say this is maybe one of the main benefits of native image when it comes to resources consumption, because if you're deploying your applications to the cloud, and chances are that you are, usually memory is something that is more expensive. So if you want to have applications that run with very low CPU and also very little memory, native image could be a way to go for you. Clearly, if you hit this application with more load, you would need to allocate more resources for it as that load increases. But the bottom line here is if you want to have a minimal overhead from the runtime, so from the actual execution engine of your application, native image can do that for you. Now, let's go ahead to our little README, which is the plan for today. So we talked about the overview of GraalVM. We have talked about migrating a Spring application to GraalVM. And now I want to talk about a topic that maybe will be a bit less kind of fun and exciting, but it is important if you want to use GraalVM in production. So how do you use libraries with GraalVM, and what is the challenge here? So you might have heard some people tell you sometimes that GraalVM doesn't support reflection. Did you hear that ever? Almost the same amount of people who said that they're using native image. OK. GraalVM does support reflection, and native image namely also supports reflection, but there are things that you need to know. So reflection in its nature is very dynamic. Normally, this is something that happens at runtime and is resolved at runtime. So if we are compiling an application ahead of time under closed world assumption, technically we cannot know what will happen at runtime and how exactly that reflection call will be resolved. What to do about it? There are things that you can do. One is that native image can detect some of the reflection calls automatically. So for something more simple and predictable and trivial, such as, I don't know, class for name, native image can detect that out of the box. But what to do with more complex cases, and usually reflection, but also GNI serialization proxies, that is something that can prevent you if you want to use a library with native image, if the library is maybe a bit older and hasn't added support for native image yet. So let's see if we can quickly cover this part where you can, how would you use libraries with native image? And there, the main suspect when I'm talking about libraries and potential challenges, the main suspect there will be reflection, because if your library fails to build, could be multiple reasons, but likely it will be reflection. So what to do and how can you use reflection and libraries using reflection in GraalVM? And here is our complete recipe for using libraries with GraalVM, going from the best case scenario to a scenario which requires a bit more work from your side. So the best case scenario is we see this trend lately where libraries, especially new libraries, are being published and developed in a way that is native image friendly out of the box. So we see this sometimes from maintainers where they say, I have developed this new library, it's fully reflection-free, very friendly towards GraalVM and native image. And this is a new trend, but it is emerging, and more people say that reflection is a powerful tool and a helpful tool, but it does add a bit of overhead. So some of them start developing those libraries without relying that heavily on reflection. That would be the best case scenario. Now, what to do if you want to use some existing library that existed around before GraalVM and native image became popular, and clearly it wasn't designed in that reflection-free, native image-friendly way. For that case, our dictionary application that I have shown you before, I liked showing that one demo because as a database, it was using H2. And in the past, I was using another demo where I built an application using H2, but then it would fail because it used reflection, and I showed you how to fix it. But now I don't have to use it anymore. It just works out of the box. And that is because H2 added in its source code config file for native image. So again, if you happen to be a library maintainer or talking to a library maintainer, if you want to make it friendly towards GraalVM, the best thing you can do is to add to your library source code those configuration files. For them, you can find a spec on our website. And what you need to do is you need to tell us that in this and that class, under a certain condition, I want to use reflection. So please mark those classes as reachable as you are building the application. And the best case, again, is if a library supplies this file within the library itself. What we will do when we build the application, we will look in this known location, so meta-inf native image, and we are instructed to look in that location for config files and pick them up as we are building your app. So this is another good case. But also, we realize that many of the libraries are open source projects, and it's not always that they have big teams behind them, supporting them and adding new features and support for other projects. So what to do if your library hasn't added this config for GraalVM yet? You would think that it would be nice if there existed something kind of like Maven Central, but for those kind of configuration of files. So let's say if I figured out config for H2, another person next to me doesn't have to do the same job because maybe they can reuse my config. We thought the same thing, and for that, we created together with our community this reachability repo on GitHub, which basically contains a big list of such config files for many popular libraries out there. Let's take a look at, I don't know, OpenTelemetry. And here, each folder represents a project and sub-projects within that project and specific versions. So if you drill down here, it contains the same similar reflect.json file. Okay, the Wi-Fi at the conference doesn't want to work with me anymore. But yes, this is a community-maintained project on GitHub, and this is the reason why I asked you to use our Maven and Gradle plugins if possible, because our plugins are instructed to go and look in this repo for available config. So let's say you want to use OpenTelemetry and you are using our plugins. As you are building your project, our plugin will come here and pull this config and make the library work for you. This is not the only way to do things, but this greatly simplifies your life if you are using libraries, if you are using our plugins. So going back here, so those three first bullet points were a more fortunate scenario. And if you are starting a new project now in 2025, I would say you will be somewhere here where a library either ships config for GraalVM within the library itself, or we have that available in that community-maintained repo. Now, quickly going through other cases where, let's say, you want to use something that is not, doesn't officially support GraalVM. Maybe you work at, I don't know, a bank or some organization where you have your internal developed libraries, and clearly there is no config out there in the open source for your library. What to do in that case? In that case, it helps greatly if you are on a version of framework that is rather new. So for example, for Spring Boot, this will be 3.0 and higher, where there is support for GraalVM and native image, and the same applies to Micronaut, Quarkus, Halidon, etc. Because what is possible to do in that case, if I know where specifically in my project that kind of reflection occurs, I can go to my source code and having that support from my framework. What I can do, let's say here we are making this slightly weird reflection call from our reflection controller to another message class. And we are passing it in a slightly weird way to try and confuse and outsmart native image, because if this was a bit more kind of sane and predictable, native image would have guessed it out of the box. So for demo purposes, we are doing it in a more elaborate way. And the way to fix it is because I'm on a Spring version that is new, and it has support for GraalVM. What I can do here is I can use an annotation from the Spring framework and say, please register this for me for reflection, and I need to specify where that reflection occurs. In my case, it's a message class. And then when you are building your project, when this Spring AOT phase is kicked in, it will look at my project and it will generate those config files for me. Granted, this is still a bit of manual work, but I would argue that doing this programmatically is still better than writing config files manually. OK, So this was if you want to make some library that doesn't work with GraalVM work with GraalVM, and you have support from your framework. But what to do if you're maybe also on the older version of framework, or maybe, again, you have some kind of internal framework that doesn't have those annotations to help you generate files automatically. In that case, you still have two more options. You can either use our tracing agent from native image to observe your application running on the JVM and output those config files for you. But then you need to hit it with a relevant workload so that we can see what the application is supposed to be doing. Or in the end, if you have one small reflection call, like I had in my controller, you can also write it manually. But hopefully, you never need to go beyond those three first bullet points. And I hope, especially if you're starting a new project right now in 2025, you will be somewhere where you are covered by library support. Phew. OK, this was maybe a bit more complicated and less exciting. But now we can switch to a more fun part. And that will be peak performance and benchmarking. I work on a compiler team. We care about peak performance a lot. And we also want to make sure that you can have with native image, in addition to fast startup and low memory usage, that you can also have good peak throughput like we are used to on the JVM. And you will see many different opinions in the Java community about JIT and IoT, which can be faster and why. Let's take all of that for a spin, and let's see if we can benchmark our application on the JVM and in native. Now, for that, we could have tried our dictionary application, but it's very trivial, and you can tell me that I'm over-optimizing a very trivial app, so we will do something a bit more elaborate. Buckle up, this is going to be a bit more complicated. So you probably know the Spring Path Clinic application. It's a fairly standard benchmarking app in the Spring and Java ecosystem, where it's a web app, and you can create visits. You can add paths, read data, write data. It emulates your kind of enterprise web Spring application. So we will take that one for a spin, and we will do benchmarking, which is not proper benchmarking. As Piotr said this morning, don't call Shipilo. This is not proper benchmarking at a conference, but this is as close to it as I can do in maybe 5 minutes. So this will be our setup. I will use a bunch of scripts to speed up my work, and this will be our first benchmarking run. So first, we will run our application on the JVM, and as a JVM, I will use GraalVM because I don't have any other installations, if I'm being honest, but I'm turning off the GraalVM compiler, and this means that I'm falling back onto your normal C2 OpenJDK compiler. Then we are starting the Spring Path Clinic application, and we are also starting the PS record tool that will observe our process and will produce for us nice charts showing resources consumption of our process. Then we are starting the application, and for 10 seconds, we are just giving it a chance to start. So we are not even sending any requests in yet. We are just saying, do your housekeeping, start, and be ready to warm up. Then we are warming up for 10 seconds, and then for 20 seconds, we are doing the actual benchmarking run. So this is still not entirely scientific, but scientific enough for a conference talk. Let's run this. Bench JIT C2. OK, and the reason why I'm giving it 10 seconds to start is because my observation is that on this machine, it takes maybe 5 seconds to start, but just to be on the safe side, we will give it 10 seconds. So it will start. Now we are actually warming up, and as it warms up, I can also tell you what is the actual load that we are sending to the app. So we are not just starting the app and sending, let's say, 1 million requests to one endpoint. We are doing something a bit more elaborate, where we have this workload defined in a Lua script. And then the load itself is create an owner, create a path, schedule a visit, read data about the owners. So we are trying to be a bit more smart and sophisticated and hit different endpoints and both read and write data. So this is not overly optimized for one specific endpoint. OK, so this has finished running. And here are some numbers. So for our warming up round, we had 468 requests per second. And then when the JVM warmed up, and we all know that the JVM warms up, we arrived at 1.4. So almost, I would say, 3x speed up. Looks very nice, but let's see if we can do the same on native image. So on native image, we will do the exact same setup with starting, warming up, and then benchmarking, but we will do the same on the native image application. OK, so this is now running, and it's also waiting 10 seconds, so we can have apples-to-apples comparison, but honestly, it doesn't have to. It's just wasted time in this case, but we want to have completely fair comparison. Now, who thinks this will be faster than the first one, than the JIT? OK, some people, but not too many. I think you're not giving me enough credit. Like, I work on GraalVM. I could have passed some magical flag to make it, I don't know, just print a faster peak throughput or something. Like, I don't think you give me enough credit. But let's see. So it warms up, and even as it warms up, you can see that it is somewhat faster already than the warming up round on the JVM. But now the final results arrive, and they are slower. So on the JVM, we were at 1.4K, and here we are at 1.2. Now, here I could have said all the disclaimers that, guys, the JVM is an amazing piece of engineering. It's very hard to beat the JVM at its own game. We are trying our best, but there isn't much that we can do. But I do have one more trick up my sleeve. So let's see if we can make it faster. So here I will run something with an intriguing name called bench native optimized. Let's see how that goes. So as this runs, I will quickly tell you, for the sake of saving time, what's inside that application. So what is there? We did a number of things. One is we did PGO. PGO is profile-guided optimizations, and this is an optimization in a way inspired by the profiling that the JVM does. You might know that the JVM, and one of the reasons why it is so good at peak throughput is because as your application runs, it observes your application behavior and it optimizes for that specific behavior that it sees at runtime. So each part of the application that becomes warm, the JVM knows that it makes more sense to invest those compilation effort into that part because that is performance critical part. And that applies to methods, to loops, to all kinds of things. And for native image, people will tell me sometimes, but you guys are building things ahead of time, so you don't have access to that profile information. Yes, we are aware, and for that we have introduced PGO, which works in a way that you can build an instrumented version of this application, run it with relevant workload, and what we will do, we will collect that profiling information in a similar way how the JVM does, only we would do that in that dedicated, separate, instrumented run. And when you shut down that instrumented application, it will output the profiles file for your application, and we can use that information to build an app that is aware of your application's runtime behavior. So in a way, we are combining the best of both worlds because we are still optimizing ahead of time, so we can take our time and resources to invest more and optimize better. But also, we have this runtime awareness that normally only the JVM has. And you might tell me that it's not as good as profiling live like the JVM does, but the thing is that native image has an interesting advantage here over the JVM, and that is that the closed world assumption, the thing that might make reflection, for example, more tricky with native image, also gives us an advantage there because we are closing the world, so we know that nothing unknown will happen at runtime. So in a way, we have a better understanding of the project because nothing new, nothing unknown can happen at runtime. So in a way, we have a more complete view of the application than the JVM can have because nothing new can happen. So this app is built with PGO. Very quickly, because I don't have much time, PGO does require this two-step process where you are building an instrumented version, running, then building again with the profiles. And I understand that not every application is performance critical, so maybe you don't want to do this two-step process. And you would think that in 2025, in the age of AI, it would be nice to have some kind of AI solution to not doing those two steps. And we thought the same thing. So if you are not giving us any profiles, out of the box, we will use an ML version of PGO, where we are looking at your application during one build, so you don't have to do two builds anymore. And we will try to predict which parts of your application will be warm. And clearly, this will not be as accurate as those profiles that you would collect yourself and give to us, but it can give you maybe 8% performance improvement over not having any profiles in the first place. And I would say that for ML, this is still pretty good. So this application, the last one that I'm running, it was built with PGO. It was built with the G1 GC. You can have different GC strategies, but overall, for peak throughput, G1 is something that we would recommend. And it's also built with the MARC native flag, which is saying, please optimize for the specific hardware features of this machine. I'm not building for distribution, so make the most out of this specific hardware. With all the build-up, let's look at the numbers. So our JVM was at 1.4K, and now native image is at 1.5 something. So clearly, there is a bit of fluctuations. This is sometimes faster, sometimes slower, but typically it will be on par with the JVM. Now, clearly, here I need to tell you a disclaimer that this is just one benchmark, test on your own workload. Don't rely on the numbers that you see at a conference. But the TLDR here is that you can have a very good peak performance with a native image application if you apply those additional optimizations and you take this time and effort to optimize for peak throughput. Then, in addition to startup and memory usage, you can also have very good peak throughput. But as this was running, we were doing one more thing. We were also observing the application's resources consumption. So let's quickly look at those numbers. OK, this is our JIT. This is our native image. And this is our native optimized. Now, I don't know about you, but I love benchmarks, and I love looking at charts. And those are particularly interesting. So the way to read this is the following. This is JIT, native, and native optimized. And what we see on the chart, the vertical red lines, this is CPU usage, and the horizontal blue line, it is memory usage. Now, all three applications ran with the same settings. For example, memory was limited to 512 megs, but they all ended up consuming different amount of resources. And a few observations that I personally have here, maybe you will have other observations, is that the JVM version of the app, remember, we were waiting 10 seconds in the beginning to start because we wanted to give the JVM the chance to kind of clean up and do all the housekeeping work. So it was indeed quite busy for 5 seconds. And the native version of the application, it started and it was just waiting. So there was way less overhead, way less work for the application to do. We could have run it very fast from the very beginning. When it comes to memory, the JVM one went a bit through the roof. Maybe I need to adjust my chart settings a bit to accommodate that consumption. But then native application out of the box, that one that was a bit slower, that one consumed very little memory, around 200 megs. And the one that had better peak throughput, it did consume a bit more memory than the plain native one, but still less than the JVM. This is, in general, like a common observation, I would say, when you are doing benchmarking, that if you want to have peak throughput, you need to give some resources. Normally, you trade off resources for throughput, and in this case, it is memory. This actually reminds me of the conversation that I had with my colleagues from our performance team. We internally track, I don't know, hundreds of metrics over dozens of applications, but we were talking just casually, what do you think is more important for our users? Startup performance, so time to first request and how fast our application starts, or peak throughput. So maybe I can use this as a chance to ask you guys, so for you, what is more important, like startup performance, how fast your application gets to first request? So who thinks this is important? Very few hands, okay, some. Okay, and peak throughput. Okay, everyone, that would be my guess too. Okay, and okay, just the last one, and do you care about memory consumption at all? Okay, less people. Okay, peak throughput it is. So hopefully with this demo, I kind of convinced you that you can have also good peak throughput with native image, but if you have any question about benchmarking or about the tooling, feel free to catch me during the break. And let me just clean this up a little bit so we can go back to our little agenda. Close to the right. OK. So we talked about peak performance. Now for deployment. I have mentioned that native image builds an application that is specific to your hardware and your operating system. So unfortunately, we don't do cross-compilation because we rely on some JDK classes that are specific to each platform. There are multiple ways around it. One thing is clearly you can do container deployments. And with native image, if you care about container size at all, you can have very minimal container sizes. Let me see if I can super quickly pull numbers for my existing app. Grab Spring. OK. So what we see here, that was a very basic Spring, basically Hello World application that I have built as a container image in the various kind of stages of optimization for size. If you happen to care about the size of your deployment, about your container images, I would not say that I'm the biggest pro at this, but for my Spring Boot application, I went from around 480 megs of the container size to just 59 megs, which I would say is pretty decent for a fully blown web Spring application. So this is built as a native image. And additionally, remember how in the beginning we were optimizing for the build time with -OB. In a similar fashion, if you want to have a very small container image or native executable, you can optimize for size with a flag that is -OS. So if you care most about the size, this could be an option for you. Another thing, and this is specifically to target kind of cross-platform builds, what you can do is, for example, I'm a big fan of GitHub Actions. Let me just pull this one up. And I think GitHub should start paying me at some point or something, because I always talk about how much I love GitHub Actions. So I have my Spring projects, for example, here set up to build every time I push or commit some changes. And here I'm building on the platforms of choice. For me, that will be Mac OS and Linux. So things like CI/CD, for example, GitHub Actions could be an easy way to build for all the platforms that you want to ship your executable to your users. OK, so this was briefly about deployment. OK. We can talk about security, or we can talk about monitoring, because I don't think I have enough time for both. I can do a raise of hands, but if I know you guys, you will probably want to see monitoring, right? Do we want to? Yeah. Could not even ask. I did this before. OK, let's see. So for that, let me navigate to a different place. What's going on here? So we will talk here about observability, and we will use Micrometer for our demo. Now, this one I have borrowed from the lovely Micrometer people. This is not my own demo, so I will now pray that it works. Let's first bring up our observability stack, and it starts. And then let's actually start the application that we will be observing and see if we can gain some insights into how our system works. Server target. So I have already them compiled to native images for the sake of having this done faster. And here we have started our server application. And now let's also start our client application, client target client. So as it starts, what happens here? So you see those two processes kind of interacting with each other. One of them is a client application that sends requests to the server, and the server that responds with information about users to the client application. And those both apps are Spring Boot applications built with Micrometer. And for me personally, Micrometer is something from the Spring world. But if you go to the website, they say that they are kind of vendor-neutral framework for observability and tracing and monitoring. And indeed, that is true, because I know, for example, that in the Micronaut space, they also have very nice support for Micrometer. And I think the same exists also in Quarkus. So it is, in a way, vendor-neutral, and it helps you collect traces and logs and metrics of your application and expose them to all different kinds of backends. So this has been running for a while. I hope you will now be able to see some data about our application. Let's go to our dashboards. OK, all good. And as I was talking, we already have some data incoming here. So for example, we see that a client application sent a request to the server. And here we can drill down and see more info about it. So maybe let's go here. Let's go to this one. And indeed, we see kind of what we saw in the command line, where our client application sent a GET request to the server. We see the duration of each operation, how long it took, and that it succeeded. And we can also drill down and expose the logs for that specific request. So again, how long it took for each particular app. Let me see. OK, maybe we can close this and move back here, because I want to talk with you about kind of future projects and what we work on with GraalVM. Let me just bring this down. OK. Very quickly about security, maybe. So in a way, native image adds additional layer of security to your Java applications, because first of all, we are eliminating everything that you are not using. So the things that you are not actively using will be removed from your project. And also because you cannot load new classes, new anything at the runtime, it also adds additional layer of security. And in a way, those limitations around reflection, serialization, proxies, etc., they also make your application more secure, because nothing unknown can happen without your control and your specific OK to let those things happen. So you need to have a wide list for those features to happen, and that makes your application also in a way more secure. But also we have support for SBOM in native image, so you can build an application with software bill of material, and then you can see what is exactly in your application, which dependencies, which versions, and better yet, you can see what depends on what. So you can, for example, see things like Spring Web will bring inside things like Spring Core, Spring Beans, etc. Now, that was about security, and I want to talk with you about what we are planning next for GraalVM. So we are working right now on a few ambitious projects that I want to share with you, and one is called native image layers. And some of those will be quite different from what I've shown you before, because we want to challenge the way native image works and see if we can take it in a whole other direction. So one thing will be native image layers, and you can think of it in the way kind of how you build container images and container deployments. So right now, the whole idea of native image is you can take your application and compile everything that you need for that app into a native executable. So what we want to do instead, we want to give you a way to build and compile your base layers separately. So let's say I have my Spring application that uses Spring Web and Spring Data. So you will be able to compile those base layers, kind of like shared libraries. And then every time you need to recompile your application, you're not recompiling the whole thing, but you are only recompiling your application code, and those base layers stay compiled. And this way, we think we can take compilation times, the ones that we saw in the beginning can take a minute or two, down to the matter of seconds, because your previous layers, your, let's say, Spring Web, Spring Data, they stay compiled, and you only recompile your application code, and then you can have very fast compilation times. One more benefit that we think will be possible is if you're deploying your application, let's say, to the cloud, and then you have several instances of the app using the same dependencies. So again, maybe my Spring Web or maybe my Micronaut data, etc. If you need the same versions of those base layers, you will be able to share them across instances. And this way, you can even further reduce resources usage in the cloud, because those base layers will be the same for your all instances. A new project that is building up on top of native image layers is called something Project Crema, and you can tell that we love coffee names in our space, so Java, coffee. So Project Crema will be a project where your top layer in this native image layer space will be in Java interpreter, and suddenly this opens the world for us. So if that top layer is interpreted, we can load new classes even in native image. So your application is a native image, it starts fast, it compiles fast, but it can load new classes, and this lifts up that closed world assumption that we have right now. This is early work. This is still will take us a while to make happen, but this will be, we think, an interesting new direction to take native image in. And then another thing that we are working on, and that one will be a bit maybe closer to arrive and closer to try out, will be something that we call Edge Preserve, and namely Edge Preserve All. Well, let's say you don't want to eliminate things from your project. Maybe you want to compile your whole thing. Maybe you don't want to do what native image normally does, where it strips away everything you don't need. Maybe you have some old project and you want just to compile the whole thing. You don't care about the size. You don't care about the compilation times. You just want to have it native. So it maybe still starts faster than on the JVM and has other advantages, but it just doesn't need any work from you to make it happen. So let's say you can have some problematic library that doesn't work with native image because some class is missing at runtime. This way, you're putting in literally everything that you have in your project in one big native executable, but then you will never, ever run into any compilation errors because your whole project is in that native executable. So this is a bit groundbreaking for us, a very new way of building native images, but we believe this can still be interesting. Now, lastly, I will not show this as a demo because I don't have much time, but with GraalVM, you can embed other languages, as I said in the beginning. And moreover, if you embed, let's say, Python in your Java application, you can still compile it as a native image. And then that native executable will be dynamically executing that Python. And you can have, for example, cute charts coming from that Python library in your native executable. And then the last one is kind of fun. I still have 20 seconds. Maybe I per second super quickly shoved it to you. JavaC. So native image is something that takes your JVM bytecode and produces a native executable. But if you think about GraalVM in the more broad terms, there is no limit to what we can take as input and output as output. The only limit is your imagination. So for example, there is nothing preventing native image from taking your JVM bytecode and outputting WebAssembly. And what we are looking at here seems like a simple Java learning page somewhere, maybe HTML or something. But what this is under the hood is JavaC, so the Java compiler that compiles our source code to bytecode, compiled to WebAssembly, and deployed, as you can see, to our website. So to show super quickly to you that this is all live, I can do maybe something like this, where I add something new. And let's say maybe I want to say hello from London, and let's do some emoji because why not? And then we can compile this, and it compiled in 67 milliseconds. And to show you that it is indeed live and compiled to bytecode live in web, I can disassemble it. And there we can see step by step what is happening in our application. So here, for example, we are invoking virtual, we are passing along our strings, and we see our string hello from London. This is very early work, but if you are interested in Java and WebAssembly, there is a very cool session from my colleagues from Mayo this year where you can learn more about it. Now, I'm a bit over time, but I promise to show you one final QR code where you can find more info, and you can also find slides if you prefer to read this session as slides. So this is the QR code that you can scan and get the slides. Now, if you want to talk to me, if you have questions, if you want GraalVM stickers, I will be here under the stage to answer your questions. And please rate this session in the app. Thank you so much for coming.